variety. So I participated in this contest already. I didn't solve that problem. Did I participate? Yeah, I solved ABCD apparently, and I couldn't solve E in the remaining hour or so. Maybe I also tried F. E is quite standard looking if you're an experienced competitive programmer, but quite annoying to code. I'm going to read the problem again, make some drawings to explain what roughly I was going to do, and then read the editorial to see if they had some nice way to approach it. Then I will implement. That's the goal. Good to know it Codeforces today, but yeah, normally I will do AdCoder though. AdCoder has very interesting problems. 3200 rating, is it? It's just hard to implement. All right, what did we have? There is a permutation. We can reverse some ranges. It costs that much. If you want to take a range of length 4, reversing it costs you 4. And in total you can spend at most C, and C is very small, at most 4. So you can reverse a single range of length 4, or like 2 ranges of length 2, or something like that. Alright, so if there's length 2, then R minus L is 1. So at most you can reverse a range of length 5. Right. She wrote down all the permutations that she could possibly obtain. What is the ith number in the jth permutation that Alice wrote down? In the jth lexicographically smallest possibly achievable permutation, what's the ith number? That's the problem. And because we care about lexicographical order, we will go from left to right. For sure. Yeah, so the basic is that we need to go from left to right. Let's do a mini lecture, but it will be, only a few minutes. If you're asked to find, let's say, kth lexicographically smallest permutation, given n and k, find kth lexicographically smallest permutation of numbers 1 through n, and print that permutation. Let's say that's the problem. Then for n equal to 4 and k equal to 3, you would need to go for permutations 1, 2, 3, 4, 1, 2, 4, 3, and 1, 3, 2, 4, and that's the answer in this example. What's the logic? What's the solution for this problem? We need to look at first number and say, if I put 1 here, what's the number of possible permutations there? All of them will come first lexicographically. There are 6 of them, 3 factorial. So whenever k is smaller or equal than this, we know that the first number is 1. If not, then apparently we skip those 6. We need to do k minus equal 6. Let's say k was 8. Then we will need second smallest permutation among those with here a 2. And now we are left with k equal to 2, if previously, initially, k was equal to 8. because we skipped already 6 permutations. That's always what happens. We iterate with first number 1, 2, 3, 4, and so on. Well, that's n-square solution, because for every next number you will try every available one, but you can speed this up by kind of dividing k by 6 factorial. Something like this will tell you what should be the first number, maybe plus minus 1. Hi, and Kurial. That's the general thing. That's what you should know. And maybe this was the most educational part of the stream. And now let's try to solve this Codeforces problem. And it's up to 30,000. There is this sequence. Let's see an example. This is some example. The sequence is n equal to 6 and 6, 5, 4, 3, 1, 2. And here c is equal to 4. It's kind of hard to analyze. But if c was 1, then this cost would allow us to only reverse 2 neighboring numbers. So we could get, for example, 6, 4, 5, 3, 1, 2 with cost 1, with just a single swap of neighbors. Alright, the lexicographically smallest sequence is 5, 6, and then 4, and so on. Basically, we need to look at the prefix. We need to see how small values we can achieve, especially in the first position. If there are ties, then what happens with the second position, and so on. We see, okay, if we do 5, 6 here, there is one way to fix the suffix because of how small c is. And if we don't do that, so if k wasn't 1, then we move with 6, and then just, continue with the suffix. If c was bigger, let's say c is indeed 4, then what numbers can I put on the first position? 4 actually allows us to reverse this interval of length 5. So I could even put 1 here, but there is just a single way to finish this. I could also put so then there is 1 something, and for this there is one way. I could put here 3 on the first position. That needs to follow with 4, 5, 6, and then this suffix will remain with c equal to 3. With this suffix and c equal to 1, there are 2 ways to do something here, because either you swap them or not. Then you can reverse this thing. 4 will be at the beginning, and then you are left with this and c equal to 2. And for that you reverse this, or that, or that, or nothing. So that's 4 ways. And so on. You continue like that. If k is 1, then you say that this is the way to go. Then if k is 2 or 3, this is the way to go. If k is 4, next possible values, and so on. You always say, if k is at most this, then take this number. Otherwise, subtract 1 from k. Then if k is up to 2, take this first number and continue. Otherwise, subtract k from 2. Hi, less you, but please use English. That's a good previous question by SM Sugara. Does a generic solution exist for non-permutations as well in less than quadratic time for this problem? I mean, I guess so. But what I described allows us to solve the problem in for single k. We can do this in, I guess, O of n, but we have q queries, so that's q times n. But I need to use the fact that c is very small, and always for a single query, only that many times I can actually reverse something, and other than that I skip big interval of doing nothing. Like there is this sequence, let's say case 500. Actually, if I do anything here, most likely the number of ways to finish this is huge. Unless the sequence is sorted, or maybe sorted decreasingly, something like that. But if I decide to reverse here, then C will decrease by 1. During a contest, I remember I tried with binary search to find the first moment where I should actually reverse two things. So until that moment, I need to know until here, if I reverse something here, then what's the number of ways to finish? I need to subtract that from K. So always, if there was something like, let's say 4, 6 here, no, if there was something like 6, 4, and I can reverse that into 4, 6, then how many ways there are to finish with the remaining C? Let's say we know that, okay, if I do this, then the number of ways to permute that with the remaining C is 20. Then I subtract K minus equal 20, well, unless K is too small. So I need to binary search, find this first place, or the rightmost place, such that the sum over those yellow number of ways to finish, if I reverse anything here on the left, that's in total smaller than K. And only then here I will reverse something. This is what I tried to do during the contest, and I didn't have enough time for that. Now I am going to check if the editorial describes the same solution or they do something better or easier. Difference between lower and... Now let's see how the editorial does it. Why does it say DP here? Because you need something to know this yellow number of ways to finish. That's what you do with DP. But it's very easy DP. Let's calculate how many ways we can apply to the array of length len with total cost less or equal to C. This is the DP part, and it's very easy. So this yellow thing is something that we can compute as DP of the remaining length, or let's say n, and remaining C. You can compute that for n up to max n and C up to max C. And there are some easy transitions. We can fix that many bars between neighboring elements of the array. Then there is a very nice formula. You don't even need DP. I use DP during a contest, but I see how this is some binomial coefficient. It is easy to see that the answer query depends on construction. Oh yeah, because in the problem we don't need to print the whole permutation, we need to find a specific number. Now on some position we need to print that number in the permutation. There is a set of rotations of size not larger than C. The number of possible rotations in this set doesn't exceed n times C. Oh, this is the total number of possible rotations, I agree. From every position, there are 1, 2, 3, 4, 5 possible rotations if C is equal to 4. If we can answer this query, LCK, what's the leftmost rotation on the suffix of length len? What is the leftmost rotation? Oh, yeah. They are going to find the leftmost rotation to achieve. This is what I described with binary search. Let's find this place such that in the prefix we shouldn't do anything. Fine. Let's fix any suffix. Build a long array consisting of the leftmost rotations in construction of each permutation. Do we have one permutation given first? Yes. Sorry. Let's mix any suffix. Right. Easy to see that each rotation will appear on some segment of this array. I don't understand this this thing yet. He has some COVID. I don't think so. Maybe. Determine the length of this segment. Oh. Also, to be clear, it's very bad to quickly jump to editorial. I'm not reading that because I didn't know the solution. I knew how to solve this during a contest. I remember that I struggled with implementation, took me a lot of time. I didn't get accepted, didn't finish the code, and I still know a solution. I know how I could code it. I just want to see if editorial presents some better way. If yes, I will implement that way, not mine with, well, it will for sure be similar. But this is something I didn't realize, and it's very nice that now I know it. We don't need DP. Well, still with DP I will compute binomial coefficients, but that's very standard part. All right, I think this is sorted array of possible, maybe not. Each rotation will appear in some segment of this array. What do they mean by some segment? Is this some sorted array? In competitive problems, what is more important topic? I don't know, both. How do you want to solve problems if you don't know one of these topics? I think they mean a sorted array. Let's try to understand. We had some permutation in the input, and there is some suffix. Say 4813. And c is equal to 2. So we cannot reverse everything, but in particular we can get 1843 if we reverse this. We cannot get 3 here. We can leave a 4. 4183, 4831, and then we can mess it up more. 8413, 8431. Did I miss something? Oh, there is also the one where we don't do anything. 4813. Let me know in chat if I missed something. This allows us to reverse something of length 3. Oh, after 4 there can be 318, right? 318. The number of these should be 2 plus 1 for doing nothing, plus this, that's 4, and also 7, I think. I got 7, all right. Now, let's investigate what's the leftmost rotation. Four, 8, 1, 3, here it's nothing. 4, 8, 3, 1, 8, 4, 1, 3, 8, 4, 1, 3. Okay. So I think they wanted to say that this yellow thing repeats for some time, and that's it. It's not that here I will find 8, 4, and here I will find 8, 4. If yes, then I agree. All right. And what next? We can determine the length of this segment. If it was the rotation LR, then there is some number of ways to finish, depending on the suffix, the remaining suffix, sure. In particular, once this happened. For x minus 1, relative order of these segments won't change. Only C segments will appear, those rotations. Oh, so if I now consider what happens, and yeah, this is not how I thought about the problem during a contest. Damn it. Yeah, if now I add something new, let's say element 2 here, then sure, all of those, they get a 2, but also I get possibilities coming from reversing, for example, this. This is 4, 2. Each of those, they get 2 at the beginning, but now also I get 4, 2, and so on. Fine. You can show that the new segment will appear only in the beginning and in the end. Oh, that's very nice. I thought that now we are going into some BST territory where I will keep some kind of dynamic sequence where I have intervals. A moment ago, the intervals were like this, that. Like in every range, there's the same yellow leftmost rotation. And then I insert something in the middle. I need to answer queries about k smallest thing, so k from the top, but not really. We always insert at the beginning or in the middle because only here we have 2's at the beginning, otherwise it will be a different number. So here they use the fact that it's a permutation, not a sequence. I think in my solution I didn't use it, and this is why my implementation was uglier. Can show that query this is equivalent to query nck. What is L? What is N? What is K prime? LCK. What is the leftmost rotation on the suffix of length len? If we have C coins. Right, what is K prime? I think something is missing in this editorial. In this we can build this array using deque. Do this for each C. What array? Iterate in order of decreasing C. And I didn't solve the problem offline. I did everything online. Sort queries in order of increasing K. I had binary search indeed. Order of increasing k. We don't even have k in the input, right? Okay, so they renamed variables a little bit. Let's try to figure this out. One moment though. Sorry, I'm back. Will you implement the solution? Yes, I will. Invite the Radeusz, he solved it. What's the point? Whoever wrote the editorial also solved it. And I told you, I also know how to solve it, just I think I'm using a solution that they mentioned here. How long the stream will take? However long it will take me to implement this. Should be around 40 minutes. For now, I don't understand this. Let's say at most it should take 1 hour. All right, so I will for now ignore what they wrote here because I don't understand it. Let's see how I would use this observation to solve the problem. We get multiple queries, and I know that they want a solution offline. There will be some number of stuff, extra new stuff here and there. Is deque something that can push to both front and end? Was that deque? That might makes a lot of sense because of this. Yes? Okay, cool. Hard problems from LeetCode? I do LeetCode on Thursdays. I don't know why you're suggesting that or asking about it. 2 weeks ago I did hard problems. Well, not from LeetCode, from binary search, but same thing. Well, if I'm mainly interested in the number of new things here, I guess. I don't see how this is important. Well, it is important to say to which interval exactly I go, because it's not that I get a bunch of stuff here and there. Actually, each of those is of some types, because it depends on the yellow interval. Like in this case, we can reverse for 2 or 2 for 8. So the prefix will be for 2 or 8 for 2. If C was bigger than or also 1, 8 for 2, and that would be here at the beginning because 1 is smaller than 2. Watch anime? Not really. I think because every permutation I want to construct looking from the left, I will first go from the right to construct all of that using the queue. Then I will have stuff in some order depending on where this yellow thing is. So I will have an array of size n times c, size O of n times c, with information like, let's say only for this I would have info that, well, I can reverse, let's focus on blue numbers. I could reverse interval 1, 3, and there is one way for that, to finish. I could reverse interval from 2 to 3, this is this interval, one way to finish. 2, 4, one way to finish. Nothing, so like 5, 4, one way to finish. Here we have something with two ways. First this 3, 4, one way to finish, and 1, 2, two ways to finish. Okay, I have this array of pairs, or the queue, of size n times c, and how do we solve the problem? We need to find, given k, I need to say to which bracket I go. Let's say k is 4. Then I know that this has total of 3, so I go there. And I know the first rotation. K is, let's say now 6. Well, that eats all of those, total of 5, and we go there. Same for k equal to 7. For k equal to 8, there is no solution. All right, and then we need to continue in some way. Let's say that we went, I don't know, here, or let's say here. Then we need to start from index 3 now, forward, with some decreased k. And there was some array built at that point. I can remember it. Or I can, this blue array, actually I built it going from the right. I can remember what happened with it. And now going from the left, I can erase topmost and bottommost elements multiple times. Also, all of that depends on C. For every C, I have this array of times n times C. Because this number depends on the remaining C. For every C, keep this array of size n times C. For every query, we will, like, I guess, binary search this moment, first moment where the sum of values so far is smaller than you, or so the last such moment. And then move to the right, and to move to the right I need to remember how this array was created as I went from the right, because I kept, maybe before array was like that, and then I added elements here, but then going to from left to right I will just keep erasing elements like that. Or yeah, I will just erase first and last element if there are ones here. This is how I can remove the full first column. Is that right? Because I cannot touch the first column. Yeah, that's easy. I will need some offset, I guess, for this. Because now k changes a little bit. If I pre-computed prefix sums, then prefix sums will change by whatever is the sum here at the top. I don't like this problem. I mean, this solution is cool. My solution from the contest wasn't cool, for sure. The one with... I didn't use the fact that those are permutations. I binary search always the next moment where something will happen. But it was ugly. writing path. I don't have anything that I would suggest you. I have something in my FAQ. You will find the model. I don't know. I didn't use others, so I don't have any comparison. Right, I think I know enough to start implementing. No, I didn't want to close. I didn't want to close that. I think I know everything. Okay, what to do with multiple queries? Because I go from left to right, I will indeed do the problem offline, even though I know how to do it online. Just, you know, all of that we can do in a more persistent way. But we'll do it offline. So what we will, for every start, I think we will push queries to the right. Always for every query, I know that now it should look at index, some index I. This is index in the blue thing. Not the one, this is not I from the input. So, or let's say this. We skipped already this. This is value from 0 to n, comma, the remaining C. So at every such pair, there will be a group of indices of queries that are still to be resolved, or like pairs, query index, comma, remaining K. So for this we have pairs, remaining K, and query index, comma, remaining K. Multiple of them. As I go from left to right, for every C, I do this. Cool. Then I can just focus on the biggest C first, then on the next C, and so on. Then my main for loop will be over decreasing C. And then over this from left to right. Because this yellow stuff is also something I build based on C. All right, cool. Please, guys, use English in the chat. That's strange. Twitch asked me if I want to block some kind of message, and I don't know. I thought it was some garbage. It wasn't in English. Some few short words. I don't even know if it was any language or just spam. And now I see that instead of just muting that message, single message, what I achieved is I blocked a term ho, but it wasn't with E. It was just HO. I didn't have anything against HO. Well. Do we use DP in this problem? You can do it for the easy part of computing the number of ways to finish a suffix with some remaining C. The editorial says that there is a formula for that anyway. During a contest I use DP, but it's like 1% of difficulty of a problem. Indeed, it has difficulty of 3200. I don't think it deserves it. I remember me, I've solved 40 of them now. 40 of what? If you're referring to something in DMs, then come on, don't spam the stream. Wait, I need to run Genie, and there might be some stuff from Petrozavod's camp. And organizers asked not to show it for a month. Right. I want to transition from using scanf to using scene, so let's try. Scanf and printf is just ugly. Oh, also this, I need to fix the resolution, which is something that I still didn't do fully to make it automatic. Always need to copy paste those 3 lines. Will it be enough if I just add it at the end of bash rc? All right. I think it's like uneven. Anyway. But I don't think we can do it without the p. What? The suffix part? The editorial said how to do it with Combinatorics. Do I want indices from 0 to n-1? I guess so. And from 0 to this. Actually, does it matter at all? I think I will only use the fact that they are distinct. I think they could be distinct and not from 1 to n. But just to make sure, let's do it from 0 to n-1. Maybe not necessary. Now there are queries. For every query ID. There's position and k. I don't want to use ij, those are terrible names for variables. It can be easily mixed up. You often just find k, lexicographically smallest sequence, so let's go with k. Okay, now what was it? For every prefix skipped and c, so initially that's 0 and c, we push back this pair. So for some kind of to-do queries of 0 and the remaining, where's c? Oh, c is constant for all the queries. I thought that c is given for every query. To-do of 0 c and push back a pair of position to solve. The remaining k is something we for sure need. And I need at least this to know where to print, but also the position. This is position that we need to print to the output. The number at this position is what they ask about. This, and there's also query ID. Query ID, position -1, we go from 0 to n-1. So, okay, this had nothing to do with that. That was position. This is the value. Position and k. I will call this max C. Most of the time I will use C as the current C. What do they want? I think that c equal to 0 isn't really interesting, but maybe so those maybe comments are kind of to do for me. This is query. Is to do a good name? Queries to do. Yeah. This is vector of queries to do for every position, maybe up from 0 to n, and like that. And you shouldn't use arrays like that, so actually it's vector of stupid vectors. What do I want to go first? Maybe max c, because I will mainly operate. This is the first for loop, so I guess I want the first for loop to be over c, the first dimension. And this is vector of query, but it's empty. What was here? 0. Cool. For every c, we go from right to left to construct the queue and to remember the operations. No, I will know how to keep erasing. Maybe as I go I need to prefix sums as well. No, just compute them at the end. So for everything from right to left, there is here some queue of stuff. Can I define like this? I can. But what actually I want is, let's see, information about interval to reverse and the number of ways to finish. So a pair of ints and a long. This is leftmost reverse. Already at the beginning, I would say that actually ways is something that can be a function, because based on this, I know what's the remaining suffix, I know the remaining c, assuming that we know the current c. But anyway, here already the push this of n minus 1 and 1 way. This is empty reverse. No push. C++ dequeue. Kickstarter CodeGem. CodeGem is much more difficult. It's even written on their website. Kickstart is for beginners. CodeGem is the championship. Dequeue reads as dequeue or dec. I think it's dequeue, just like Q. But if you tell me it's dec, I can believe that. Push back and push front. Here, of course, it doesn't matter. I could guess that. Well, if there are two possible directions, I need to specify. Fine. For every next thing, there are some new reverses to be made. The length of this, not this cost, cannot exceed C. Is that correct? For C equal to 1, I'm allowed that. Okay, fine. Reverse interval ij. Let's consider this. It will go before or above, but also we need to sort in some way. All right. We have this and information about that. Then I will need to compare them. I want to sort according to, like, literally this interval reversed. So this is the interval from I to j. All right, reverse. And now those are possibilities. Those intervals starting from I. Oh, I do it for every I separately. But if I just do this, also this is such a big word. I don't want that. Ints for intervals. Intervals is a good name. Dun, dun, dun. The reverse. Actually, right now I don't need to do this because I will know the length from the length of the vector. So those are just a vector. This, right? Push back the interval, sort them, and now for each of them, move to the beginning or the end of the deque. Every interval. Now there is comparison to be made. I think it's just this one. Also, only for that, for non-trivial reverses. I think this is the comparison to be made. What happens is when I said that we discover a new element 2, green 2 here. Now, if we consider reversing, for example, for 2, it will go after 2's because 4 is bigger than 2. So I'm comparing, after reversing the first element of reversed interval, with a 2, an element that anyway stands here if I don't reverse. If this, then this push front of now interval, or actually rev based on interval, else push back. This is in wrong order, so we need to fix that. But first, from L to R, that's I, J, not J. J needs to come from this. I plus len minus 1 is J, and ways. That's to do because I didn't compute it. How to prepare for IOI? Solve a lot of IOI problems. Read this. Okay, this is ref, this is ref. And if I sorted stuff and there is something small, then if I have, let's say, elements 1, 2, 3, and then also 7, 8, 9, if in this order I go and I push front 1, 2, 3, and then push back 7, 8, 9 to something, then those will not be sorted, because if I push front 1 first, then it will go somewhere, then 2 will go in front of it. So for this case, I should reverse the intervals. Right, if interval of 0 is greater than p of 0, also assert that there is no equality. Reverse. And well, let's copy paste. Don't want to copy paste. Let's repeat twice. Right, now if repeat is 0, so without the reverse, and this is big value, lexicographically big, the push back. This is lexicographically small, it goes to the front. Now I need to do ways, maybe not now. Let's finish this part. Ways is something separate that goes as pre-processing. So this is what? Step 1, build the queue, going from right to left. Then we need to compute, I believe, prefix sums, but for now let's not do it. For now let's do it in quadratic time. From left to right, insert queries and push them further to the right. There will be to do prefix sums. But for now I will not do it. I will just, with brute force, count in this long queue where I should be. Okay, but we finished some thought, then we can move to ways. When you solve the problem, are you imagining what the operations looks like in your head? I did hundreds of hours of streams now. You're able to see how I solve the problems, I make drawings. Like, I made this to explain to you this problem and then to analyze what the editorial said, which I didn't understood first. This is what I do. Visualize this often with some examples. Ways. That's the number of ways to deal with a suffix of length. J is this. Maybe J is not a good word. This is R, where L is I, whatever. Okay. From I to J I reverse. And what is the number of ways to finish where you are left that much? And C is decreased by this. And again, let's skip this. In order, C goes first. This is the remaining C, this is the remaining length. Not really, this should say -1. Now that's the remaining length. If J is n minus 1, I want this to be 0. Alright. This is preprocessing, not dependent on, so as 0. And this is something during a contest I did with DP, not with Combinatorics. I didn't realize that it's Combinatorics. So what way should I go with now? I don't know. Nekinti, what spam are you pasting here? Are you left-handed? No, I'm not. So if there is 0, then for anything, this should be defined as 1. And otherwise, what they said is for C, it just, if you have some elements, you can put at most C bars here, and that represents some kind of reverse. You have n-1 spots to put bars between, so it's like choose from n-1 to C. Did I get it correctly? Let's see. Yeah, that's it. So I want first preprocessing for binomial coefficients. What's the most I can do is, what is n? I wonder if long is enough. Okay, long is enough. N to 4th power fits in long. All right. For every C, from 1 to max C, maybe from 0, we'll see. For every n, okay, for every length, again, maybe from 1, not from 0. Plus the choose function for n-1, comma, yeah, this would not work properly, comma C, and now to know this, you can use the previous value. Okay, let's do it with brute force. It can be done a bit better. This is B. Right, and I didn't do length equal to 1 and C equal to 1. Would all of that work automatically for C equal to 0? Then this is 1. Alright, so let's do this. And we're good. This is easy part, so please somebody tell me if I messed it up. And we have NC square, but you could easily get NC. But I think we don't have overflows here. I remember during the contest I was afraid of overflows in my solution, long overflows. Maybe at some moments I would get more than 10 to 19th power. All right, then we have this. Cool. From left to right. Answer queries and push them to the right. So we gather queries in some to-do thing. What does it mean? We're interested in the current deck queue. As we go through it using ways, we can know where we should go with our K, and then possibly we reverse the first interval. And anyway, we decrease K, but whatever in skipped prefix. So later I will use prefix sums and here binary search over this over those prefix sums. But I want to get at least pass samples first with this, then I will add prefix sums. If solution has like 10 different parts and you can easily replace some of them with brute force first, then it's easy, it's nice to do it first, check if everything works, and only then replace those slow parts. This is especially convenient during Olympiads, where you're not penalized for wrong submissions or like slow submissions, and you get partial points. Right, for everything in the queue, can I iterate over auto if? Does that work? It works. This is of that type. Yeah. To do binary search on prefix sums. Right. If this is strictly greater than the number of ways here, like there are 5 ways to finish this and case 6, and we continue. Otherwise, something nice happens, because we know that we should make this reverse. If query dot position is smaller than the L, if position that we ask about is on the left from the reversed interval, then we know the answer for this guy is just the default one on this position. Next, if otherwise, if this position is up to R, then it means the position is in the interval. There was interval from L to R, and there is some position inside, and we reverse this interval. Then I claim that we need to take L plus R minus the position. And again break. And otherwise, we reverse something and we still go to the right. So to do of, what's the remaining C? It's this thing. And what's the remaining, what? The position. Query. And it already has properly decreased K. This is, I guess, also break. And actually for every query, if ways to do U smaller than K. And this, then I'm guaranteed that something will happen here, but some assert would be nice for that. But it's complicated. Like at every break, I could say I could set some Boolean flag as true, and here I would make sure that something happened. How do I do it? Okay, let's do it with Boolean flag. Step mate. What is wrong? Answer not declared. Long or int? Int. And I think we're done. Well, it's a slow solution because we don't use prefix sums. No, we're not done. I need to update the queue. As I go from left to right, after I'm done with this, I need to, from the beginning and the end, remove stuff with I as the part of reversed interval. Front L is I. Wish me good luck. Oh, that wasn't correct. Oh, I decrease values by 1, don't I? Yeah, I think that's unnecessary. I don't use values. I use the fact that they are distinct, because only then things go to the beginning or the end. Oh, something's wrong. 3 instead of 0. Oh, I don't save some answer. All right. But accuracy is much better than I expected. What is going on here? Oh, those are 2 test cases. Oh, then let's separate them. Already here I get 0, and 0 basically means that I didn't save answer for somebody. It's very suspicious. Maybe because I don't go with I up to n? But I don't think that should be necessary. So it's this guy. Third position if k is equal to 3. 1 to 3, single reverse. What is the third one? The number of queries. Okay, then we have 1 to 3 if we do nothing, 2 1 3, 1 3 2, and yeah, this goes here. Those are the 3 options. So indeed 3 is the answer. I should reverse this. I see 0. The remaining C is 0. Nothing will be messed up because of that. For every I, this is empty. Repeat twice this. But then this part is important. From left to right, answer queries. Yeah, this is fine. Even though C equal to 0 can be dealt with easier. I mean, can be dealt with easily with an if. I don't think that's necessary. So let's get again the whole input. All right. I pass samples. That was smooth enough. And now what's left is to build prefix sums on the deck. I think this is something where I would be worried about overflows. But well, that some of that doesn't exceed the number of ways in total, and that's, yeah, that doesn't exceed n choose 4, so that's good. This is pref sum of size this size. spec plus refways. Should I push back 0? Ah, yeah, let's do it for convenience. Pref now is bigger by 1 than d dot size. Right, this is now prefix sums. For every query, what do I need? Let's say that number of ways are 2, 2, 2, 2. What happens for k equal to 5? I need to find u, because the sum in this prefix was smaller, strictly smaller than k. So if this, then I need to go forward, otherwise backwards. I'm looking for element out of those, but I need to use prefixes, and those have the extra 0. I'm investigating if this is a good candidate. If prefix of the mid, that's sum up to this. It's like that, right? Yeah, sum up to the previous element. If this is smaller than k, then this is good element, and maybe even need to find something earlier. This is small enough. No, later. Wait, what? If this is small enough, yeah, later. So we need to find bigger prefix. Like that. And now, oh yeah, and the size of the queue changes. Right. This works if the queue starts from index 0 and prefixes are like that too. Let's go with first is 0, last is this. This is remaining interval to search in. Oh, I know what I should have done. Before I added prefix sums, this thing that worked for the sample test, I need to copy it. Okay, now copy this to brute ECPP. And now let's work with that. This means that we get this element on the queue, but I don't get constant access for the queue, right? It's kind of a list. All right. Then I will copy the queue into a vector. I don't know if this initialization works, but let's try. And now I can access, but here I cannot conveniently remove the first element. I will still do that on the queue, and we'll just update first and last. So here it says that I need to use the vector of best. Everything before I used to decrease query k. Best minus 1. If this is 0, plus 1 again. If 0, then 0. Yeah. I know that I can remove this, but it has more meaning for me like that. I do have constant access? Really? Oh, add. Oh, cool. Then I don't need this. Add of best minus first. When doing this first plus plus, doing this last minus minus, and additionally there is some offset for prefix sums. Oh, I do something with that. What do I need to do? This logic. This logic is something I still need. Right, and the offset for prefix sums. Whenever doing this, offset plus equal ways, and now when I'm accessing any kind of prefix, actually decrease it by offset. I'm a little bit scared of what happened. Passes the sample test. I need to do what's left. I mean, this to do is fine. It was just my name for an array. I don't understand. Well, sometimes for very hard problems I would answer neither do I. But here it wasn't that hard. Stupid solution? I mean, I don't know. Runtime error. Well, runtime errors are easy to fix. I can use instead of add the brackets you tell me. Where's the add? Oh. Then thank you. Thank you, Itarin. Now, I could go through my code and read it and try to understand the runtime error. This is what I would need to do during a contest. If I had already a generator of small random tests, then I could run it and wait till my program breaks for some reason. Also, the runtime, this is big time. From this, I would guess that maybe something bad happens, like I have too small of an array or something like that, because n is big. But here, let's scroll down and see it. Runtime error, exit code is free. C++, exit code free. Uncaught exception, but alloc. I guess that the deque, for example, maybe I access some non-existing element of deque. Assert didn't fail. Prefixes, I think, are of proper size. Well, like that. Right. This will check my theory about accessing non-existing element of the queue. But if this doesn't give me runtime error because of assert, then maybe let's use a generator of random tests. Stupid is not a friendly word. Sorry about that. Wait, what did I call stupid, by the way? Something in my code? Okay, nothing changed, so it's not this. Something stars vector of pointers to the constant size arrays. All right, makes sense. It can double the size when needed. But I also heard that deque is very slow and inefficient. I think it has big constant factor, big overhead as well. But I wasn't fully sure if this is like, I use deque once every year. How to generate a random test? Create a program that will generate random values. Yeah, I can implement a vector. Actually, here it would be very easy to do it as a vector, where I just keep index to say where is the first element. Sure. I just didn't. I thought that the easiest way for me to fix the code to access an element is to copy it into a vector. Right, so what, a generator? How complicated the input is? Not really. Okay, so this does work here. The test is too big for me to take it and analyze what happens. I don't even know which line fails. So, yeah. I even have a gen.cpp file here. Right, do I save something between tests? No, nothing global. That's nice. Then for now I will assume that single test case is enough, but sometimes you need to try several because maybe you don't clear an array between tests. N C Q. There is function iota for that, I remember, but I always just write a for loop before I think how before I like spend time thinking, oh, how exactly to use that iota thing. Shuffle. This is random shuffle in this test lib library. So yeah, this is how to generate a random test. Let's see if it makes any sense, if the formatting is good. Also for convenience, let's add some empty lines here and over there. My program doesn't care about empty lines. It will be just easier to read. What did I do? Oh yeah, I wanted to do it before and after printing the permutation P. The generator now takes a random seed and generates a test. So think of length 4, C is 2, 3 queries, indeed, the first value is from 1 to n. Seems good. And now in the for loop, E on int or break. Best is not -1, so my assert failed. Well, maybe that test had something else, but I thought that this I would see that assert failed if assert failed. Do you move with mouse or pen? It's a mix. Like, if I want to here move to the end of the line or something like that, I use end or home. But let's say here, so right now I'm using keyboard, but I don't know, maybe here to do something like uncomment this line, I would point with a mouse. So now I'm using a mix of both. Right, let's create a very small counter test. That one is too big. Maybe this will be enough. N is up to 2, C is 1, Q is 1. No. Q doesn't matter much, does it? Okay, C. Let's try C up to 2. A lot of minus ones. Should it all be minus ones? Oh no, there are some ones. All right, apparently we need n equal to 3. Let's try with c equal to 1. I would save a little bit of time for compilation if I provided arguments for this generator. Instead, I change something here, recompile, lose a few seconds because recompilation is slow. It's not perfect. Before I spend time, this is too big for sure for my values. Maybe I missed some test because of that. Okay, up to 7 should be enough. I hope. Let's use 10. That's a pretty small test. 3 to 1, k is 4. Let's see. Do we have c is 2? So in particular, you can reverse everything. Yep. You can do nothing, or do this, or do that, or do this. That's 4 ways. Fine. When does this... By the way, asserts are very good. Otherwise, something random-ish would happen. And here I see exactly that this is the case. There is some C, I guess. Making a video on testing interactive programs. I mean, yeah, I would consider. First is 0 and last is -1. So the queue is empty. This empty element is something I shouldn't remove. Well, but it has L equal to N. So it shouldn't be removed. Unless I get to I equal to N. I don't see how it got removed. Yeah. At what point can I remove this from the queue? First and last. Where do I create them? Here. Actually, why this guy wasn't removed? You pop back instead of pop front? Thank you. Thank you. Who noticed that? Itarin again. Thank you. Thank you a lot. Use English. Timeout. All right. Does it still work? Works for the first sample. I can as well use this with a bit bigger constraints. To see if there isn't any runtime error. I'm compiling differently with a different button. It's more debug stuff will be checked. Submit again. Light music is good with coding. Not for focus. I sometimes listen to fast piano music, but only if I'm doing something very easy. And now wrong answer is something more difficult to debug. And I really want to finish in the next few minutes because at 7 p.m. I have classes that I teach. Let's just see how I keep the answer. It's if this is before the interval to reverse, then do this at the end. Do I print? No, never mind. Okay, here this plus looks good. C minus the cost used there, starting from there, pushback query. Looks good. How many people solve this live? I don't know. We can check. A handful, around 10. All right, what do I want to do? I want to do it fast. So copy somebody's submission. Grab it. I already have a generator. Compare this with that. And we found a counter test. This is a counter test, but for sure I want something smaller. Done. Oh, this is not a permutation. Good. Okay, sorry. This is NCQ. So already for C equal to 1 it doesn't work. This is the permutation. What's the order? This is the position, and in the first one I say 3, he says 2. Well, there's 1, 2, 3. In the first one it's indeed 1, 2, 3. So So it should be this kind of reverse. My program, when realizing that something is the answer, it can say what's the interval to replace. I'm now worried that maybe I'm finding the empty one and I'm not treating it properly, but let's see. I'm looking for this line. Yes, it's the empty one. So I need to say if this or division r is n, because this means an empty interval. Otherwise, I incorrectly hit this case. Nope, that's not the case. Oh wait, that is just incorrect to say that it should be empty interval. Damn it. Good at debugging? Not really, if I didn't find it yet. What classes? Oh, they are just for Polish students preparing for Olympiad. So if you're not Polish, you shouldn't be interested. I just teach. I and Marek Sokolowski, MNBV Mar on Codeforces, we teach in one high school in Warsaw. It's for free. Well, most of classes like that for students are for free. Right, I incorrectly say that I go there. Okay, 14 minutes. Damn it. So we start with this. I can reverse something. The first one is 1, 2, 3. Second is 1, 3, 2. And then 3, 1, 2. We're looking for, this is the position, right? The first one. We're looking for this. Maybe it's off by 1 error. If this is strictly smaller, yeah, then this is good. Offset plus equal that. Looks good. So first should be the reverse. Do I print this? I do. I'm interested in lines with LR and ways. Those. Empty, reverse this, reverse that. That's not a good order. This shouldn't be first. Is it because I don't properly sort compared to something empty? Let's see. This says that the lexicographically smallest case is if I do nothing. All right. What is this? Interval of 0 compared with P of 0? That was quite wrong. I should look at the current element, not at the 0th element. Right. But you see, thanks to a small test, I realized that okay, order is wrong, so apparently I sorted incorrectly. Then I looked at proper part. This is part responsible for sorting, and I noticed a mistake. Just looking at 200 line code, it's hard to notice that single line with mistake. All right. So I expected to solve this problem in around 1 hour. Took almost 2 hours. Well, happens. Right. I was a little bit scared looking at that running on test 5, but seems good. How much for you to do my online assessment for me? $1 million. Test 150. So I still think that it was hard to come up with that solution. Normally we go from left to right and we do this binary search thing where the next reverse should happen, which was possible, just a little bit harder. 2 seconds out of how much? 3. My code is quite slow, but also they mentioned in the tutorial that here you can sort better, here something, yeah. And I know that dequeue is very slow. I'm sure that it would be better to use a vector and an extra variable to say what's really the first element. Assuming that dequeue is the bottleneck here, I actually didn't think about it. C times, I built a dequeue of size n. Maybe that shouldn't be a bottleneck if there is nc square in some other place. I have, where do I use binary search? Here. Every query will be handled c times at most. So q times c times logarithm, but a very small constant factor. I don't know. I'm not sure which part is really a bottleneck. I would need to test by measuring time, I guess. Tips for typing faster? Practice with some programs to get proper placement of your fingers. Dequeue is pretty fast. No, it isn't. I think it's a few times slower than vector. I wanted to find some discussion on this, but I don't. Well, I might be wrong. It's just something I remember, not something that I'm sure of. Performance tip using TQS memory. What does this say about dequeus? I think this says something about speeding it up. Yeah, this doesn't confirm what I'm saying either. I just remember that dequeue is slow. Anyway, of course, if I'm wrong, just tell me in YouTube comments later. I will pin it. I don't want to spread misinformation. Something like vector of pointers to chunks. I don't know how it's implemented. I just think it has big overhead. Maybe it's just for not slow? Okay, if so many people say so. Is it at least true that small dequeue has big memory overhead? Do competitive, what, never will able to, like if you're blind or something, maybe you can do some level of competitive programming. In Python, dequeue is faster than list. Okay, but that's Python. I'm talking about specific std dequeue. And I think it is slow, but maybe I remember that for small structures. I remember that it's significantly slower and shouldn't be used. Maybe because just it has big overhead. Like, let's say 30 kilobytes, 30 bytes. What value makes sense? Tens of bytes per empty structure. 4 kilobytes? What, 4 kilobytes per empty dequeue? I don't want to guess. If somebody knows that well, please let me know in comments in YouTube. Performance of DEQ. What is this? But I need to go. Iterating over DEQ 50% slower than vector. All right, that's something already. But I'm guessing right now that the worst thing about DEQ is to have a lot of small DEQs, like 1 million DEQs of size 5. All right, I really need to go, so thank you for watching. Bye-bye. And if somebody's streaming on Codeforces, I will rate them. Nope. So, see ya.